Good day, everyone. Welcome in physical science. So before we start, we'll be having a pre-test. Direction modified true or false on a space at the left. Write true if the statement is true. If the statement is false, so change the italicized word to make it correct. Or you can use a sheet of paper with you. So number one, a catalyst is substance that can be added to a reaction to increase the reaction rate without getting consumed in the process. The answer is true. 2. Heat is not a catalyst since it can't be taken out of the reaction in the same amount it was imputed into the reaction. So the answer is true. 3. Catalysts increase the rates of chemical reaction by raising the activation energy of the reaction. The answer is lowering. 4. Collisions only results in a reaction if the particles collide with a certain maximum energy called the activation energy of the reaction. The answer is minimum. 5. A chemical reaction may be energetically favorable, for example, exothermic. And so, if the activation barrier is high, for example, the activation energy is high, the reaction rate may be extremely slow. So the answer is true. 6. Decreasing the concentration of reactants increases the collision frequency between reacting particles. The answer is increasing. 7. Increasing the concentration of the substance increases the kinetic energy of the particles that make up the substance. The answer is true. 8. Raising the temperature of the reaction increases the rate of the reaction by increasing the energy of the collisions between reacting particles. The answer is true. 9. Lowering the surface area of the reactant increases the rate of the reaction. The answer is true. 10. Catalysts permit reactions to proceed along a higher energy path. The answer is lower. 11. Smaller particle size allows for a larger surface area to be exposed for the reaction. The answer is true. 12. Temperature is the measure of how much area of an object is exposed. The answer is surface area. 13. Grains of sugar have a greater surface area than a solid cube of sugar of the same mass, and therefore we dissolve quicker in water. The answer is true. 14. Decreasing the temperature causes the particles, this is atoms or molecules, of the reactants to move more quickly so that they collide with each other more frequently and with more energy. The answer is increasing. 15. Catalyst describes the area that atoms, ions, and molecules must collide in order to react. The answer is collision theory. Now, today we'll be having the discussion about catalysts. For objectives, okay, so after going through this lesson, you are expected to 1. Describe the concept of catalyst, present catalyst as an effective means of affecting the reaction rate. 2. Realize the importance of catalyst and how it affects your life. Reaction rate generally increased with increasing reactant concentrations, increasing the temperature, and the addition of a catalyst. So physical properties such as high solubility also increase reaction rates. Solvent polarity can either increase or decrease the rate of reaction, but increasing a solvent viscosity generally decreases reaction rates. Although a balanced chemical equation for a reaction describes the quantitative relationships between the amounts of reactants present and the amounts of products that can be formed, it gives us no information about whether or how fast a given reaction will occur. This information is obtained by studying the chemical kinetics of a reaction, which depend on various factors: reactant concentrations, temperature, physical states, and surface areas of reactants. and solvent and catalyst properties if either are present. By studying the kinetics of the reaction, chemists gain insights into how to control reaction conditions to achieve a desired outcome. Now, in this figure, it shows how temperature affects the rate of reaction as it increases the kinetic energy of the molecules, thus increasing their chances of overcoming the energy barriers they need to have reaction to go to completion. Now, we'll be having an activity. So, word search, search and encircle to unlock the pool of words in the box, then use them by filling in the blanks to complete the passage. Okay, so we have here factors affecting the rate of reactants. Excellent, you are good in analyzing information. As a reward, I will share a story with you. So, wow, I do love hearing stories. Can't wait any longer, Professor X. I am more than glad and happy hearing that from you. I'll just get my book and read it for you. Maria and Pedro met in Mr. Valara's first grade class. They were friends all through grade school, high school, and college. They're friends and family members, although that they should date, but they never did, and the people around them began to get impatient. Finally, their friends Sarah and Juan took the matter into their own hands. Sarah asked Maria to go a concert with her, and Juan asked Pedro to go to the same concert with him. And the last minute, Sarah and Juan canceled, leaving Maria and Pedro to attend the concert together. They began dating and later got married. What a happy ending! They are very lucky for having friends like Sarah and Juan. They act like catalysts in their relationship. In chemistry, it is any substance that increases the rate of the reaction without itself being consumed. One good example are enzymes that are naturally occurring catalysts responsible for essential biochemical reactions. For example, in this figure 2, apples go brown when their flesh reacts with air. In the pictures below, which apple will go brown the quickest and why? We have letter A, letter B, letter C, and letter D. So the answer is letter D. Apple D will go brown the quickest since apple's flesh reacts to air. It makes apple B, C, D to go brown slower than A. And by applying the factors affecting the rate of the reaction, it will be the one with smallest surface area. Hence, letter D. The process of the reaction that takes place here when an enzyme reacts to air is enzymatic browning. Now, for the key terms, activation energy means the minimum energy required for a reaction to occur. Catalyst, the increase in the rate of a chemical reaction by lowering its activation energy. Transition rate, state, an intermediate state during a chemical reaction that has a higher energy than the reactants or the products. Maxwell-Boltzmann distribution, a probability distribution used for describing the speeds of various particles within a stationary container at a specific temperature. The distribution is often represented with a graph with a y-axis defined as the number of molecules and the x-axis defined as the speed. Now, the effect of catalyst on the rate reactions. This part explains how adding a catalyst affects the rate of reaction. It assumes familiarity with the basic concepts in the collisions theory of reaction rates and with the Maxwell-Boltzmann distribution of molecular energies in a gas. A catalyst is a substance which speeds up a reaction, but it's chemically unchanged at its end. When the reaction has finished, the mass of catalyst is the same as the beginning. Several examples of catalyst reactions and their respective catalysts are given below. We have reaction rate and catalyst. So, for example, the compositions of hydrogen peroxide. So the catalyst is manganese oxide, nitration of benzene. The catalyst is concentrated sulfuric acid. Manufacture of ammonia by Haber process. So we have catalyst of iron, conversion of sodium dioxide into sodium dioxide during the contact process to make sulfuric acid, and the catalyst is vanadium oxide. So hydrogenation of a C to C double bond, carbon carbon double bond. So the catalyst is nickel. The importance of activation energy: collisions only result in a reaction if the particles collide with a certain minimum energy called the activation energy for a reaction. The positions of activation energy can be determined on the Maxwell-Boltzmann distribution. So here we have the number of particles, okay? And in this area, this is what we call the number of particles represented by the area under this part of the curve doesn't have enough energy to react. But in this area, it is represented that this area or this part of the curve has a high enough energy to react. And this is the point of activation energy. Only those particles represented by the area to the right of the activation energy will react when they collide. The majority do not have enough energy and will simply bounce apart. To increase the rate of reaction, the number of successful collisions must be increased. One possible way of doing this is to provide an alternative way for the reaction to happen, which has lower activation energy. In other words, to move the activation energy to the left on the graph, so we'll be having here an, a new activation energy. All right, so in this part, we have particles who don't have enough energy. So now all these extra particles have enough energy to react. Only the particles by the area under this part of the particles have enough energy to react. So it means that this is a new activation energy, and this is the original activation energy, and this is the energy. Adding a catalyst has this effect on the activation energy. A catalyst provides an alternative route for the reaction with lower activation energy. This is illustrated on the following energy profile. Catalyst is one of the factors that can affect the rate of the reactions along with the concentrations, temperatures, and size of the particles as discussed on the previous lesson. So today we'll be having an activity. So answer the guide questions below after watching each video. So we have link 1, link 2. Okay, so link 1 guide questions. What is a catalyst? Second, how does catalyst work? Third, in the video, where are catalysts used in everyday life? Link 2 guide questions. What substance in the experiment contains catalyst that helps in the reaction? Second, what happens when the yeast is added to the hydrogen peroxide? 3. What enzyme catalyst was produced by the substance? 4. How would you differentiate catalyst from the temperature as a factor affecting the rate of the reaction? Fifth, what is the significance of putting flame on the solution in the experiment? Another one is, just like a catalyst explained in science, there are also some factors that may affect us to grow or hinder our rate of success. It may include your family, friends, opportunities, or your personality. Will you share it with me? Who, what are the influencers in your life? Write it on your journal. Now for our assessment, so the direction choose the layer of the best answer and write it on an extra sheet. So 1, how does a catalyst work in speeding up a reaction? A, it lowers the activation energy. B, it provides more energy. C, it creates more reactants. D, it increases the temperature. 2, the minimum amount of energy needed for colliding particles to react is called the blank. A, chemical energy. B, activation energy. C, kinetic energy. D, potential energy. 3. A substance that increases the rate of the reaction without being used up during the reaction is called A blank. A, catalyst. B, reactant. C, product. D, solute. 4. Catalysts permit reactions to proceed along an energy path. So A, higher. B, lower. C, restricted. D, stubler. 5. What is an enzyme? A. An inorganic substance added to food for better digestion. B. An organic molecule that dissolves nutrients in the body. C. A biomolecule that releases energy during chemical reactions. D. A biomolecule that serves as catalyst in biological system. C. 6. Which of the following explains why products molecules are not formed despite numerous collisions? Choose all that apply. A. Number of collisions. B. Activation energy. C. Orientation. D. Energy released by reaction. 7. How is catalyst different from a reactant? A. Adding more catalyst speeds up the rate of the reaction. B. Adding more catalyst slows down the rate of reaction. C. The catalyst is not used up in the reaction. D. The catalyst increases the activation energy of the reaction. 8. Which of the following increases the speed of reaction? Choose all that apply. A. Raising the temperature. B. Adding more reactants. C. Adding a catalyst. D. Adding more products. 9. The rate of chemical reaction is not affected by which of the following: A. Temperature. B. Particle size. C. Concentration. D. None of this. 10. Products will form faster if A. The, the particle size of the reactants are larger. B. Temperature is decreased. C. The concentrations of the reactants are increased. D. The reaction is not stirred. 11. Choose two options that will increase the rate of reaction. A. Reducing heat. B. Adding heat. C. Adding catalyst. D. Removing catalyst. 12. Which of the following will lower the rate of reaction? A. Adding an enzyme to the reaction. B. Decreasing the temperature from 40 degrees Celsius to 10 degrees Celsius. C. Breaking a chunk of calcium up into smaller pieces. D. Increasing the amount of solute dissolved in solution. 13. Smaller particle size result to a surface area to be exposed for the reaction. A. Larger. B. Reaction. C. Smaller. D. Spherical. 14. Which of the following is not a characteristic of a catalyst? A. It participates in the reaction. B. It activates equilibrium. C. It enhances the equilibrium rate. D. It initializes the reaction. 15. What must happen before a chemical reaction can begin? A. The activation energy must be exceeded. B. The activation energy must be reached. C. The concentration of reactants molecules must be reduced. D. The concentration of products and reactants must be equal. Okay, so the answers are number 1A, 2B, C, 3A, 4B, 5C, 6C and D, 7C, 8A, B, C, 9D, 10C, 11B and C, 12B, 13A, 14A, 15B. Now for your additional activities, in your most creative way, how will you define catalyst and describe how it affects reaction rate? It can be through a song, a role play, experiment, a poem, a poster, or an interpretative dance. A 5-minute video performance will be evaluated using a common rubric to given by the teacher. And of course, this is an individual, okay, so it's a virtual only. So you can do a 5-minute performance. And thank you everyone for listening and have a good day.